All right, this is our last video for week 2. We're going to talk about geometric probability distributions. If a random variable x is geometric, then we can say that x follows a geometric distribution, and you'll notice that we write that as x tilde g, and that a geometric distribution only depends on the probability of success. There's no number of trials here because we don't know how many trials we'll need. So that means our expected value and our standard deviation are going to change. For the expected value, it is 1 over the probability of success. For example, if I flip a single coin, I know the probability of success is 0.5. So 1 divided by 0.5 would be 2. I would expect to see my first heads on the second flip, on average. The standard deviation is the square root of 1 over p, our mean, times 1 over p minus 1. Again, I don't expect you to have these memorized. That's why this class is opened up. So in this case, for flipping coins, I know that 1 over 0.5 is 2, so it's 2 times 2 minus 1, which is 1. So it's 2, and then square root of 2, so 1 point something. For probabilities, it's a little bit more direct. I know that I am going to need a certain number of trials to get my first success, and that all of the trials before that were failures. So if my first success occurs on the A trial, I must have had failures with a probability of 1 minus p for A minus 1 of those trials, and then a success on the last one. You'll notice here there's no exponent. It's implied to be 1. A minus 1 plus 1 is A, so we have the right number of probabilities there. I have a string of failures followed by a success on the last trial. For less than or equal to A, it's the same idea that we saw with binomial. I'm going to add up, I don't know why I did that, all of the probabilities for x equal to 0, x equal to 1, all the way up to x equals A. And this, just like binomial, is cumulative. I'm adding as I go all the way up to the 8th trial. So I'm going to have a PDF for the exact value and a CDF for the cumulative value. And these patterns are going to follow exactly the same pattern that we saw on our binomial. So I know that to get to the distribution menu, I'm going to press second and then vars, and that'll open the distribution menu. And then we're going to take a look at that and see if we can find where geometric is. So second, vars, I know it's going to be towards the bottom. For me, it's the last two, E and F. E and F. And again, a reminder, this guy is the PDF. He's the exact value. These guys are over a range of values. They're going to be CDFs, cumulatives. So for x equals A, we want E, which is Geomet PDF. And we're going to go take a look at what Geomet PDF asks for. So if I go down to Geomet PDF, it asks for P and my X value. P and X value. So P and A. CDF for less than or equal to is going to work the same way, except it's going to be CDF. So CDF, P and A. If I want less than A and not less than or equal to A, I need to drop that X value down 1. So geomet CDF P A minus 1. I remember that this guy is the complement of this guy, so I'm going to do 1 minus this. So 1 minus geomet CDF PA. And I know that this is the complement of this, so I'm going to do 1 minus that guy. Let's go ahead and do an example so we can see what this looks like in practice. So for this example, it says the literacy rate for a nation measures the proportion of people age 15 and older who can read and write. The literacy rate for women in Afghanistan is 12%. Let X equal the number of Afghan women you ask until one says that she is literate. What is the probability distribution of X? What is the probability that you ask 5 women before one says she's literate? What is the probability you must ask 10 women? Find the mean and standard deviation. So first question saying, what is the probability distribution? So I know I'm keeping track of the number of trials I do until I get a success. And everything else looks like a binomial. So this is geometric. And the probability of success, finding someone who says they can read, is 12%. So 0.12. B says, what's the probability you asked exactly 5 women before one says she is literate? So this is P, X equals 5. So we know that that's going to be geomet PDF probability of success, number of trials we need to get our first success. So let's go ahead and plug that in our calculator. So geomet PDF, probability of success, number of trials, and we get 0.72 if I round that, 0.72. So we expect that there is a 7% chance I'm going to need exactly 5 trials before I get my first success. For C, it says, what is the probability you must ask 10 women? So in this case, this is X equals 10, which means this is going to be the same function, geomet PDF, 0.12, but now it's 10. So second vars all the way down, 0.12, 10, and we get 0.38 if I round that up. So a little bit less than 4% chance. For D, it says find the mean and standard deviation. So mean of X, or expected value, standard deviation of X. I know the mean is 1 divided by the probability of success. So 1 divided by 0.12, and we get 8.3. So somewhere between 5 and 10 trials on average before I see my first success. For standard deviation, I'm going to do 1 over P times 1 over P minus 1. I'm going to square root that whole thing. So we'll do that on our fancy calculator. Second square, 1 divided by 0.12, times 1 divided by 0.12 minus 1. And I get 7.8. Which is almost as big as our mean. This is a much bigger spread. So I could have a wide variety of answers, a wide number of trials before I encounter somebody who says she's literate. That could still be considered reasonable. Could be as low as 5, could be way above 10, because this is my measure of spread, and it's almost as big as my mean. So there's a wide range of answers that would be considered probable and reasonable. All right, so that's it for week 2. If you have any questions, feel free to send me an email. Drop by my office hours on Tuesday or Thursday. Otherwise, I will see you next week.